So many of you in the chapter 3 challenge problems, I'm looking specifically at the um, the ATM example. You struggled with what are you going to do as a developer to make it easy for the user to make a selection. So in that example, you'll recall we have an automatic teller machine, and in that machine, we have a $500 amount that's available for withdrawal. Your withdrawal amounts were 20, 40, 80, and 400. Not sensical, it's just what they happen to be. And what did you do as a developer to get the user to be able to withdraw an appropriate amount? So the only solution that was available to you in chapter 3 was to say, okay, I'm going to use formatted output, and with that formatted output what I'll display is 20, 40, 80, 400. And the user has to enter an integer value, and that integer value hopefully is 20, 40, 80, 400. But what happens if the user enters 100? Now, in chapter 3, with what you have, you simply would have taken that user input, subtracted it from the total amount in your user account. You would have subtracted that 100 from the total amount that was available for withdrawal in the teller machine, and you would have been done. So it would have been not satisfactory, but it would have been correct. And the whole idea there was to leave you wanting with a little bit more. It's like a breadcrumb. And that breadcrumb leaves us here to 4.10, and that's the idea of a menu. Now, this starts on page 192, and the idea here is not one that exists like in the soul of C++. This is an idea that exists in you, the developer. It's a way to manage and reduce the propensity for error, the option for the user to make a mistake. So rather than allowing a user to select based on entry 20, 40, 80, 100, we build a menu. And that menu says select 1 for 20, 2 for 40, 3 for 80, and 4 for 400 on the withdrawal. And what ends up happening is the user has to enter 1, 2, 3, or 4. And then we can build that into an if, else, if chain. So if user enters or user entry equals 1, right? Because we're looking for comparison, we're not looking for an assignment. We have the statement block that follows our if statement. If user selection equals 2, we have a statement block that can manage that selection. And then we would have the trailing else. The else statement there can account for the catch-all. So if you put 5, we could put an error statement in there. If you put Q, we could put an error statement in there. And it turns out to work really well. I am a big advocate here in your 276 development days and beyond for building menu structures into your user interactions. In no way, shape, or form am I trying to suggest that the user, out of this criminal malfeasance, is trying to mess with your code. You want me to deduct $400, I want to take 2. So, or what have you. They're not going to put in, what is your birth date, and they're not going to respond blueberries because F you. I'm not suggesting that that's every user, and I'm not suggesting that they are in any way, shape, or form criminally stupid either. But what I am suggesting is that a menu reduces the amount of stress point interactions between you and the user. It provides for them a simple means for associating a selection with an appropriate action. That selection and appropriate action, in turn, are easier for you to negotiate logically in the code because it's something that you can test for very, very simply if in rather an if else chain. So here you can see, with apologies there, you can see this is on page 193. And we're actually going to go through and step through this exact piece of code later on in the code sample section. So buckle in. We're going to look back over this, but you can see on line 38, now that we have a user choice, we have a really simple way of creating an if else structure here. So line number 38, if, and then inside of our parens, choice equals adult choice. And we'll talk about how we are mapping essentially a variable name. So that's our constant for the variable that the user is going to select, and we are mapping that to a numeric choice. So adult choice in this case is 1. So when the C++ during runtime, so after compiling and linking and everything else that happens, C++, when it sees inside the logic adult choice or child choice or senior choice, what it really sees is 1, 2, 3, and we can identify, and we can, in this case, select on that as if it was numerically, which is fantastic. So menu-driven interactions, 1, 2, 3, 4, A, B, C, D, whatever the case might be, are far and away better than the interactions based on the user having to hope that they are entering in the data in the same way that you are expecting the data. Drive them to a better interaction, reduce the stress points there in that computer user interaction. Reducing the stress points reduces your need for creatively thinking your way around that code, and it reduces the need for the user to wonder, are they doing this correctly? Both sides here can win, and that in general is a real win.